Hello and welcome to yet another video of Cornerstones of Math. Today we will solve the following problem. If x plus y equals a, y plus z equals b, and z plus x equals c, express x squared plus y squared plus z squared plus 3xy plus 3yz plus 3zx in terms of a, b, and c. I will solve this by two very similar but slightly different approaches. The basics are the same. We obviously have to do a bunch of polynomial algebra, but the difference arises from how we utilize these three given conditions. The first idea is pretty straightforward. We have three unknowns x, y, and z, and we have three equations, so in theory we can solve this system of equations to obtain individual expressions for x, y, and z. But here, instead of using conventional method of elimination, let's do things more smartly. Here, the equations are given in a cyclic manner, and what we can do here in this case is just add them up. Then we have 2x plus 2y plus 2z equals a plus b plus c. So dividing with 2, we have x plus y plus z equals a plus b plus c over 2. And let's call this equation 4. Then, if we calculate equation 4 minus equation 2, we can straight up obtain x, which is given as a minus b plus c over 2. And from equation 4 minus equation 3, we can obtain y equals a plus b minus c over 2. And from equation 4 minus equation 1, we obtain z equals minus a plus b plus c over 2. So we have obtained x, y, and z. Therefore, x squared plus y squared plus z squared plus 3xy plus 3yz plus 3zx is... If we use the famous factorization/expansion formula for x plus y plus z squared, we first have x plus y plus z squared, then we have additional xy plus yz plus zx. And here, let's write it as xy, then x plus y times z. So we can use equations 4 and 1 for this x plus y plus z and this x plus y. And for these x, y, and z, we can straight up use these expressions. So x plus y plus z, so a plus b plus c over 2 squared, plus xy, so a minus b plus c over 2 times a plus b minus c over 2, plus x plus y is just a, so a times z, which is minus a plus b plus c over 2. So the first term is a plus b plus c squared divided by 4, and for the second term, the denominator becomes 4, and let us write numerator as first a minus b minus c times a plus b minus c. And the last term is, if we use denominator 2, minus a squared plus ab plus ca. So we have, by using the common denominator 4, first a plus b plus c squared, and the next part is in the form of this famous formula, which results in squared minus square form. So we have a squared minus b minus c squared, and from the last term, we have minus 2a squared plus 2ab plus 2ca. So if we expand everything, from this part, we have this, then a squared, and from this part, we have minus b squared plus 2bc minus c squared, then minus 2a squared plus 2ab plus 2ca. Now notice that a squared, and minus 2a squared, so a squared term cancel out, b squared and minus b squared, c squared minus c squared, and 2ab here and 2ab here. So we have 4ab and 2bc here, and 2bc here. So we have 4bc, and 2ca here, and 2ca here. So we have 4ca divided by 4, which gives ab plus bc plus ca. Now, this means that x squared plus y squared plus z squared plus 3xy plus 3yz plus 3zx equals x plus y times y plus z plus y plus z times z plus x times x plus y, which is beautiful. The second method is quite similar to the first method, but in here we will not obtain individual expressions for x, y, and z. We will still use this equation 4 though. Now, instead of solving for x, y, and z, we square each equation. Then we have x squared plus 2xy plus y squared equals a squared, y squared plus 2yz plus z squared equals b squared, and z squared plus 2zx plus x squared equals c squared. And by adding them up, we obtain 2 times x squared plus y squared plus z squared plus xy plus yz plus zx equals a squared plus b squared plus c squared. And dividing by 2, we obtain x squared plus y squared plus z squared plus xy plus yz plus zx equals a squared plus b squared plus c squared divided by 2. And we will call this equation 5. And from previously obtained equation 4, if we square that one, we have, by the expansion formula of x plus y plus z squared, x squared plus y squared plus z squared plus 2xy plus 2yz plus 2zx equals a plus b plus c squared divided by 4. And let's call this equation 6. By subtracting equation 5 from equation 6, we obtain xy plus yz plus zx, which equals a plus b plus c squared divided by 4 minus a squared plus b squared plus c squared divided by 2. And we will use this xy plus yz plus zx to solve the problem. So we do the similar manipulation. First, we write x plus y plus z squared at the front. Then we have plus xy plus yz plus zx. So now we use this expression of x plus y plus z and this expression for xy plus yz plus zx. So first, for x plus y plus z squared, we have a plus b plus c squared divided by 4. And then this part gives additional a plus b plus c squared divided by 4 minus a squared plus b squared plus c squared divided by 2. Notice that first two terms give a plus b plus c squared divided by 2. So using the denominator 2, we can write minus a squared plus b squared plus c squared. So by expanding this part, can you guess what we obtain? Which equals, voila! And that's all for today's video. Thank you all for watching, and please don't forget to hit that like and subscribe buttons, and I will see you in another video.